Okay, so we looked at two more, determining the slope, y2 minus y1 over x2 minus x1. Now we are down to find the equation of a straight line from a graph. So, where should I start? Go, Dower. The bottom. Where should I start? Josephine. Y-intercept on this one is really easy to figure out. It's 0. Am I intersecting it here? Thank you. Okay, it is -5. So I have got straight off the bat C equals -5 because I am intersecting the y-axis at -5. Now I need to find my gradient. This has shown you 2 points that we should be using. See the 2 circles? That won't happen on your test. We won't do points, but you want to pick 2 points that are nice to use. For example, you would not try to use this point here. Why would I not use that point there? It's not probably. Yeah. So let's use that point there and that point there. Can anyone see another point I might be able to? I said that's -1, -2, -3, -4. Can I see another point I could use, Dower? Negative what? -3, +1. I could use that point. I could use? Yeah, Nicola? -1, -3. You can use any point that is nice onto the line. So what we do is we are going to rise first. So start with 1 point, rise. Do I rise up or down? Down. Oh, it doesn't matter, I guess. I'm going to rise down, though. I rise down. If I rise down, what is that? I'm rising by -2. Rise up. Run. I run now. How many have I run? 1. Should it be +1 or -1? All right. If you rise up, it is positive. If we rise down, it is negative. You might need to write this down because there's some confusion around the room. If you run right, it is positive. If you run left, it is negative. So we've got m equals -2 over 1. So m equals negative. So what is my final equation of my line? Well done, Ada. Okay, so which 2 points did you? Okay, so if I use the 2 circles, I go down 1, 2, 3, 4, that's -4, and I go across 1, 2. Looks like you've counted your rise incorrect. Could have used -4 over 2, but that still simplifies down to -2. Yes. That one is hard. Let me pull up another one. It just matters if it impacts the negativity or positivity of the rise. No, not necessarily. Like this one here. If I went from down to this mark here, I would go down and then I would run. Okay, and I just had a great question. Does it always run 1? Let's look. We've got in orange, it ran 2, and then in red here, what's my rise in red here now? -6, good. And what's my run here? 3, which still -6 over 3, it's positive -2. Or, guys, remember we can start at these points down right here. I could rise up. So that would be +6, and then I could run left. If I run left, what is that? -3, so I get +6 over -3, which is -2. Doesn't matter which way you go. All right, let's put a couple of these up because I think it would be good to practice. Slope from a graph. Okay, there are two graphs here. Can you guys see both of those okay, or do you want me to zoom into one? So, please try to find the equation of those lines. The first thing that we notice, what's super easy to notice on this one? Negative 1 over negative 2? 1 over 2? Okay, so if I start at this point, I go up 1, so that's plus 1. And I go right 2, that's plus 2. So m equals 1 over 2. C equals 0, because I'm just going through the y-axis at x equals 0. Y equals 0. Okay, therefore, y equals a half x plus 0. I would be looking for a half x as my final answer. Or, can I have a show of hands? Like thumbs, got it, feel good, better, glad we're doing this, cool. Okay, this one. M equals, that 1. When I look at that graph, I know straight away it can't be a positive slope. I know it can't be positive because it's starting in the top left and it's sliding down, so it's got to be negative. Okay, so if I start here and I rise, I go down 1, 2, so negative 2, and I run 1, 2, positive 2, so negative 2 over positive 2 is negative. What is my C? C. Done. Negative 3 because it goes through the x-axis, y-axis. Whoops. Y equals negative 1 times x minus 3, and we're super clever, so we don't even need to write that negative 1 out the front. How do we go with that one? Better? Okay. I have 1. What's the equation of that line? Y equals negative 1. What is the gradient of that line? 0. Good. What is the y-intercept of that line? Negative. Good. Equation for that line? Negative. X equals negative 3. What's the gradient of that line? Undefined. What's the y-intercept of that line? Does not exist. It's not through the origin, but it does not intersect at the origin. This line is never going to cross over with the y-axis. What do we call that when two lines never going to intersect? They're parallel. Good. Last one for you is a challenge. Can you figure out the formula for this line? The rule. All right, off you go. See if you can figure it out. No, that's the trick. The rule I've gotten is y plus 9. Now, how can we prove it? Option 1, gradient you guys are all pretty good at. We rise up 4, we run 1. Did we all get a gradient of 4? Okay, so no. All right, if we keep that going, we go up 4, 1, 2, 3, 4, and across 1. We are now at negative 1, comma, 1, 2, 3, 4, 5. Negative 1, comma, 5. And then I could go up 4 again, and across 1, and I would be at 0, comma, 9. That is one option. Option 2, and this is what I was looking for, but it's really quite advanced. We know this is our rule. Y equals mx plus c. What is m? 4x plus c. Now, can you pick one point on the graph, one x, y pairing? Is there one coordinate on the graph that we know? What do we know? What's one that we know? -1 is here, -2 is here, -3 is here, -4 is here. 2, -1 is over here, so no. 2, 1 is over here, so no. -2, +1. So, we know that this line goes through the points -2, +1, correct? Which one of those is x? -2. So we replace the x with -2. What should I replace y with? 1. And then I do plus c, because I don't know what c is yet. I'm trying to solve for c. 1 equals -8 plus c. Therefore, c equals? This projector's like, we need a break, and I agree. But that was good timing. Okay. What we probably do or possibly do the last step that we did to try and solve for c. Is we'll do a little bit more another time. One sec.